particular problems, please let me know which ones that I can do them for you. And I will do exercise number 1 right now that talks about producing not Q. And if you get a not Q like that, it means it's not equal. Right? So not Q means not equal. Well, then question is that right or not? Is a product 5 by 8 equal to 40 going to be not the same as 80? And the answer is yes, 40 is not the same as 80, so it is definitely a true statement. But let's do a couple of more here. So you mentioned number 13 exercise. Let's take a look at what this is. And looks like here we're dealing with or one or the other. And they actually say if we have a P and not P, which is everything on the outside of P, not P. So what happens if you take their union? Union means you take everything. Would that work? And the answer is yes, it's going to be true for all possibilities, because when you take union of two opposite statements, it means you just cover entire universe for this case. So if somebody says P is this one, that is true statement, right? Not P will be false because you reject truth, so you get the false. But if you recall how we were thinking of the truth table for the union, if we had P or Q, so last time we looked at this 4 possibilities, such as a T with a T, T with a F, F with a T, and F with the F. Then only one case when we get a false was the last one. Everything else for the case of union or disjunction was a true. And that's exactly what we happen to have here. So what do we have here? We have true, false. So when you do the P is true, not P is false, this is going to be right there, T, F. So their union will be true. So for number 13, it's true. And now I can try to do the next one, exercise number 15. So in exercise number 15, again, I need to prepare myself a little bit. And we got the pair of statements here. And we already know that not Q was worked out before, and not Q was a true statement, right? And please notice that if you already have a true statement present, then the result is going to be true, because in my definition for the disjunction, once either they both are true or just one of them is true, the result is true. Both F's is only the case when we get false result in there. But to be more precise, I can actually see that not P is a false, right? And not Q, as we saw, was a true. So when you utilize this false and a true from our little table here, false and true, what comes out is true as a result. So indeed, this statement is true. I guess we are getting used to this table use by doing these exercises. And why don't I recall another little definition that we were dealing with? That was a definition of conjunction. Like, let's say in exercise number 4, that actually, let me write this table first for conjunction. So we had PQ, but the table will be for P and Q. And they go through all 4 possibilities that you can ever encounter. So FT and then both falses. And I know that there is only one true in here. Everything else is false. Once again, this is a definition. So it's a good idea to have this someplace where you can always find it, that definition, as well as the one that we had here for the disjunction. So when I'm looking at the exercise number 4, maybe I can clear this a little bit, because it talks with a Q and P. So please notice that Q was false, right? Because 5 times 8 is not 80, but 40. And P was true, right? P was true. So if I put P, which is true, I say, Alex, first comes Q. So if I put Q, which is false, which is going to be my, looks like, row here, that starts with a false for a Q, and then true for a P. I say, but Alex, here's P and Q switched. Well, it turns out it doesn't really matter. The result will be false for the conjunction. So please notice that if you have P and Q, it doesn't really matter. If P is true and Q is false, the result is false here. And the same result you get when you switch them around, when P is false and Q is true. So it turns out these operations, people say, commute. So you can switch P and Q and you still get the same result. Please notice that same happens here in the table that we used for the previous part. So if you have TF or FT, they both give you the same result. In this case, it's both T. So it doesn't really matter if first is true or second is false. If one of them is true, then it's true. Or on the contrary, with a conjunction that we have here, if one of the results is false, the whole thing is false. So let me try to do problem number 17 to actually fill the little table in here that wants us to look at the case with not P and P. So how do we start to deal with tables? Well, it turns out on the first place, I need to consider all possibilities for statement P. And all possibilities means there could be either true or false. And again, because P is a statement. So when you have a statement, it can be only true or only false, nothing else, right? So just 2 possibilities. So that's my start. So now I need to negate both of them, which means that instead of T, I put F, because that's not P, so it means we change T with the opposite, and false we change with the opposite with a true. So I have produced the second row. Then what? Well, then I'm going to use both of these rows and look at the table with a conjunction here, the one that I just utilized in the previous exercise and get my results, which means that I'm going to look at the first row that has T and F, and this is exactly here, right? First is T, second is F. So what's my result? Well, it's F, right? It is false. So please notice that one of these two so-called quantifiers is false. The result is false when you do this conjunction type of procedure. And also, if you switch them around, if first is false and second is true, that will be the next row of my table, and it's again going to be false. So please notice that the result is always false. What does this mean? Well, if you are trying to find the intersection of P and not P, which is on the outside, the intersection of them, when you look at the sets, is going to be empty, nothing in it. So false means there is no result or empty set. And that's interesting. So let me go to the next table and next page and do some more of these little table work so we can get used to utilizing this definitions of and or. So I'm going to look at exercise number 19. And for that exercise, looks like my first column that I need to fill is going to be not P. Not P means that we need to negate everything that used to be on those positions. So I just look at positions with P. So true, I change with the opposite, with false. The other true, I change again with a false. Do you see what I'm doing? I'm looking at this entry here, and I put false. I say, Alex, what is this false? This one I don't care about right now. Right now, I just need P and not P. So I'm just looking at that particular column. So once you figured out what one needs to do to get this tables worked out, it'd be the same for all. So if I have false, I negate it, get true, and another false, I negate again and get a true. So I just filled another part of the table. So I'm ready to finish up with this exercise. And to finish with that part, now I look at the end, which is right here, the column on the left. And I guess the most convenient way to take care of it is just to look at your results. Only one true appears when both of these guys are true. So what are both of these guys? Well, right now I care about this column with a Q and that column with not P, right? I no longer care about P because here I have not P and there I have Q. So Q and not P. So when I see both of them true, which is happen to be here, you see, both true. So the result is going to be true. That's my very first row. The only case when we get a true result, when both are T. And it's right there. So TT, we'll get a T. Everything else has one F or two Fs. So everything else will be false. And this is it. So we got the answer. Everything else is false. So we use tables one step at a time. That's the point of story. One step at a time, we just look at what column or pair of columns we need. And of course, I'd like you to observe that these tables are all pretty much the same in terms of start. What does that mean? Same. Well, you have two quantifiers, P and Q. So you always have TT, TF, FT, FF. So you can compare this portion of the table with this portion of the table, it's identical. And same as with that portion of the table and etc. They all start the same way. So it's standard. So let me try, let's say, problem number 22. Practice this a little bit more. So right now I need not Q. Not Q means I need to take a Q, so I no longer care about P, and just change T's with F's and F's with T's. So here will be F, here will be T, right? Instead of T, I put F, and instead of F, I put T. So I just worked out not Q. And that feels pretty good because now I can see what's the next step. It looks like the next step is now going to use the other definition, the table here on our right side, because now we have OR, which is a disjunction, as they call it in this section. Disjunction. So what columns do I need to use? So now I need to be careful. I need P, which is right here, P. So I use this column. And I also need not Q. So I use this column. So I just need to use those two columns. I don't care for Q. See that? So once you decided what columns of this table you need, then for simplicity, I can say the only F that table has for me is when both are falses. So what I do is I get the case when both are falses, and it's right here. This one is false and this one is false. So that's the only F, right? Because for all of the others, I have either one true or both true, or in the last is the second true. So my other results are all going to be true. So I put 3 of these T's and remaining spots. So it's not that bad, right? So please notice we do quite a few exercises in this problem 22. And little by little, we're moving towards the end of that entire story. So the end of this entire story will be to take this result that we just produced, which is right here, P or not Q, and negate it. So please notice that now I'm going to work only with this new column that I produced here, and I changed them with the opposites. So the true changes with F, next true changes again with F, next is T, because I used to have F, and finally it's another F. So this is my answer. Very similar to the previous, but there were a little bit more steps. And what I would like to tell you here is that to produce this table, we were actually looking for the result P or not Q. So that's actually the ending for the entire exercise, which is the column on the very right. So that's our goal here. Technically, we don't really care what happens before. We just need to see when P is T and Q is T, turns out the result is F, and etc. So in order to get to this exact statement with the negation of P or not Q, looks like the first step was to produce that not Q. So please notice, just like we had done the priority of operations, I have parentheses here. So I need to produce expression in the parentheses, and the last step will be to negate it. So expression in the parentheses is right there, the previous step, expression in the parentheses, right? I don't want to put the check mark because we actually use it for disjunction. So it's just here. So this expression inside the parentheses. So it's right there. Now, what does it include? It includes two ingredients, P, and we have P, it's fine. The other ingredient is not Q. So that's why they also had to put not Q. And that's about it. So that's how we produce those actual tables. We get the end result, and then we try to put all of the intermediate steps in between. And that's what they actually want when we have exercises like 25, for example. I think I need to clean this because I just produced lots of mess. So let me try to clear all of my writings and just stay with the original table that I used to have here. So maybe this one is going to be gone. I just want to get a nice and clean table prepared for my next exercise. So as usual, first is T, the second is F, right? Then here we have F and next is T. So I'm very heavily utilizing these definitions, and this is going to be end Q. Please notice this is OR, so I actually needed to work on the other table. So it was not very careful, but I still cleaned the first one. Let me clear all that. It's just way too messy. I don't want to highlight anything because it might be misleading. So let's get back to this. P or Q now. So both are true. Next is T with F, right? Then we have F with a T. And there'll be 3 T's and the last is F. So yes, I memorized these, but I highly recommend that you put this table on a piece of paper so you can always find it easily and use it to do your homework or whatever exercises you want to do. So number 25 is asking you to deal with a P or not Q. So how can I produce that? Well, first of all, I noticed that P or not Q utilizes both P and not Q. So for that matter, I need to prepare myself for this. So I put both P and Q as usual. That's a standard start. Then I need to know what not Q is, because on my last step, I need to go with a P or not Q. So this is how we start. And now I go with both T, then TF. It's a standard procedure, FT, and finally FF. So this way we always start. And now I'm gonna deal only with a second column here to be able to produce not Q. So in the second column, I'm going to negate all of these. So instead of T, I put F. Instead of F, I put T. Instead of T again, I put F. Instead of F again, I put T. So I produced the next column right away. Okay. So again, I look only at the column with Q, and that's how I produced not Q. So next step is coming, and the next step calls me for finding what is P or Q is, but you're actually dealing with P or not Q, which means that we only care for the first column that has P, it's right here, and the third column, which is not Q, the third column. So what I have to do is compare my entries in a table above. So here's T and F, right? I need to find T and F in my column definition, in my definition table above. So do you see the result is T? I say, Alex, why is it T? Well, it's right here. So when first is T, second is F, right? The result is T. So here's my first T, second is F. I say, Alex, what about this one? Well, this one we don't care for. Right now, we're only dealing with P or not Q. So Q is not present at all. It used to be there because we utilized it to help us, but no longer present. Okay, so next row, second, I have both of them true. So what do you think the result is going to be? Well, looks like I'm looking at the first row in my definition, and the result here is T. So I put down T, just like that. Okay, then what? Well, then we have next pair, both of them are F. You see, this is F and this is F. So when both are Fs, I have result which is also false, F. So what about the last one? How about if you tell me for a little quiz for today, what you're gonna put as a last entry in your table for the exercise that we just started to do?